Hello, welcome back. In this video, we're going to look at object-oriented programming and how that's done in Python. Object-oriented programming is a type of programming paradigm where you separate your program into objects, where you use objects to store state. That might be very vague right now, but if you're not familiar with the concept, we're going to look at it through some examples. But it is a very vast concept. We are only going to scratch the surface, learn the basics of classes and objects, and hopefully see how that's very useful from a programming point of view. And also, as we covered earlier, Python helps us, program object-oriented programs, structured programs, functional programs. So Python basically supports multiple paradigms. In this example, we're going to look at how it solves for object-oriented programming. Now let's switch to the editor, and I'm going to create something called an employee. So I'm going to name the file employee test.py. So just follow along as we go through. I'll explain what we are doing. And as I said earlier, you define classes and objects in object-oriented programming. A class is nothing but a blueprint of a real-world object. Let's say we want to define an employee, right? So you will say class employee colon. Now you will think about what are all the properties that are tied to an employee. It could be name, could be age, can be salary. So those are all properties that are common to all employees. So what class helps us do is define a blueprint. So using that blueprint, you can define 1, 10, 100, or thousands of employees. And all of them will share the same properties that you define within the class. You will almost always define a method called __ init __. This has a special meaning to Python. This is sometimes you call a constructor. This is what you use to set values to a particular object. So if I create an object of this class employee, I will be using this init method to assign values to that object. So we'll just go through this. Again, it might be vague right now, but when we run this program, I will explain again, and that will make things much more clearer. So you'll start with something called the self. Again, this can be named anything, but the first parameter you give to a constructor has a special meaning. Just keep that in mind for now. And let's say we want to define a name for the employee, age, and a salary. So that should be good. So if you remember, you'll always do a colon to start a new function block. And here, we'll type self.name equals name, self.age equals age. And again, I'm going to explain all this in a little bit. Salary. So that should be good for now. Now I'm going to end both of those blocks, the function block and the class block. And now I'm going to create an object called E1. And you will create the object by using the class name. And we are passing 3 properties. So ignore the self. Self is not a property you would pass. Self is a property you use within the constructor. We're just going to pass name, age, let's say 30, and salary, we'll just say 10,000.25, just to pass a float. Let me save it. Let me run it. So the program finished successfully. So the good thing is there were no errors. It executed fine, but nothing is displayed because we didn't ask anything to be printed. Now I'm going to add a function to print, and we're going to run it again. And at that point, we can kind of go through the details of what happened. Self, colon, here I'm going to print I'll just say self.name, print self.age, and print self.salary. And I'll just print something to like a header or something. Print employee details. And let's call the function. So e1 dot print employee. I'm saving it. I'm running it again. So this time we have something printed. So now let's go through it again and see what happened. So we defined a class employee. Like I said earlier, a class is nothing but a blueprint. We're saying any particular employee that we create will have a set of properties and will share this print employee method, or will have the print employee method. So we're creating a class employee. We're using the constructor, which is always in the syntax, underscore underscore init underscore underscore. That has a special meaning to Python. We're passing in a self. Again, like I said, this doesn't have to be self. It can be anything. I can change it to self2, 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 and self2. If I run it again, nothing will change. So this is not a special name. It is a special parameter, right? The first parameter to the constructor always has a meaning, but the name has no significance. You can use any name you want, followed by whatever properties that we want the class to have. So we want the employee class or employee blueprint to have name, age, and salary. And then we're using the self to assign it. So assign the values to the object. So what's going on here is we're saying this class has a name, age, and salary. Constructor is getting some values passed, and we're saying whatever values were passed as in name, age, and salary, assign to the object's names, age, and salary. So self means the object that we are currently talking about or that we are currently working with. We're saying assign the name, age, and salary passed in the constructor to the name, age, and salary properties or attributes of the object. Which is why if I quickly jump here, when we create a new object of employee, we pass John, 30, and a number, which actually gets assigned to these parameters, name, age, and salary, just like a normal function call. But to differentiate between the parameters of the function and the object's attributes, you use something like a self or self2. Hope that's clear now why we are having a self2. It's just to differentiate between the object's properties, with the function's parameters. And similarly, we have a print employee function that again takes in a self, because we have to again talk about specifically the object's properties. And we're saying when this is called, print the name, age, and salary of the employee. And that's exactly what happened here. You can create another employee, E2 employee, and this time we'll call him Mike, 40, and then 20,000.56, and then call e2.print employee. If I run this, so we have employee details, John, 30, and the first one, right? So we called the constructor, passed the values, created an object E1 of the class employee, and printed it. And then now we have created a different object, E2, for a different employee, and printed his details. So slowly, I think you can see the power of object-oriented programming, where you define a blueprint once and you can use it to define any number of objects. And all of those objects will share the properties you defined once and the functions you defined once. So this is one of the key features of object-oriented programming. Why that, it makes it powerful, that you're able to define a class and you can create as many objects as you want with encapsulated properties and functions. So that's a main example I wanted to show about classes and objects. One final thing is you can add another property too. So you can say, oops, sorry about that. You can add, let's location. Let's say I want to add another property. You just have to do self2 dot location equals location, and then when we print it, we can print self dot location. And then when we create the object, we just have to pass in, let's say this employee is in Chicago and this employee, let's say, is in New York. I'm saving it, running it. So now you see John 30 salary, and then Chicago, Mike 40 salary, and then New York. So as you can see, we are able to simply make few changes to add a new property to the class, thereby adding the same property to all the objects. And one final thing I wanted to point out about the significance of this parameter is that, like I said, the name doesn't matter. Only the position of the parameter matters, right? Here it's self2, but here it's self. But the program works fine. So just keep in mind that self is just something easy to show that we're talking about the object, but it can be any name that you use. You just have to make sure it's the first parameter in the constructor, and you use something like that in any of the functions as well. So that's the example I want to show about classes and objects. I hope it helped you understand object-oriented programming a little bit if you are new to it. But if you're not new to this, if you had used that in other programming languages, this program hopefully would have shown you how to do that same thing in Python. Thanks for watching. See you in the next video.